It's the most iconic planet in the solar system, a gas giant wrapped in colossal rings that stretch for hundreds of thousands of kilometers. Saturn isn't just beautiful, it's massive, powerful, and mysterious. This planet isn't solid, yet it's dense enough to shape the fates of its moons. Its atmosphere is a swirl of storms and jet streams, and its rings, so delicate from afar, are born from violence, gravity, and time. But there's more. Saturn's moon Titan has an atmosphere thicker than Earth's. And Enceladus, another icy moon, is shooting water vapor into space, maybe even from a hidden ocean below. In this documentary, we'll explore the structure of Saturn, its stunning ring system, its diverse moons, and the spacecraft that revealed it all. We'll dive into the mysteries that remain, and why Saturn may hold secrets to planetary formation across the galaxy. This is the story of Saturn, the Lord of the Rings. Saturn is the sixth planet from the Sun, orbiting at a distance of about 1.4 billion kilometers, or 886 million miles. It's the second largest planet in our solar system. Only Jupiter is bigger. But in many ways, Saturn is stranger. Its diameter spans 120,500 kilometers, more than 9 Earths wide. But its density? It's so low that Saturn could float in water if you could find a bathtub big enough. That's because Saturn is made mostly of hydrogen and helium with no solid surface. It's a swirling ball of gas and liquid layered over a small rocky core. Like Jupiter, Saturn rotates incredibly fast, once every 10.7 hours. This rapid spin flattens the planet at the poles and widens it at the equator, giving Saturn its iconic oblate shape. Its atmosphere is composed of hydrogen, 96%, and helium, 3%, with traces of methane, ammonia, and water vapor. The outer cloud layers form subtle yellow and gold bands, more muted than Jupiter's, but no less active. Beneath those bands lie powerful jet streams, cyclones, and storms, including one shaped like a perfect hexagon. Yes, a hexagon, and we'll get to that. But Saturn isn't just a planet, it's a system. It has over 140 confirmed moons. It has a magnetic field, a powerful gravity well, and a ring system that defies belief. But the most stunning fact? Saturn's rings are only a few hundred meters thick, and yet they stretch hundreds of thousands of kilometers wide. A colossal, cosmic paradox. They are among the most recognizable features in all of astronomy, and still, no one's entirely sure how they formed. Some believe they're ancient, others say they're younger than the dinosaurs. We'll explore the rings, the moons, and the missions that revealed them. But first, let's journey through the atmosphere of Saturn itself, where storm systems rival those of Jupiter, and a polar mystery spins endlessly. Saturn's atmosphere may look smooth from afar, but beneath those pastel yellow clouds is a system of turbulent storms and jet streams moving at speeds over 1,800 kilometers per hour. That's faster than any hurricane on Earth. The atmosphere is layered with bands, alternating zones of rising and sinking gas, like Jupiter's, but less colorful and harder to spot. This muted tone is because Saturn has fewer complex molecules in its upper cloud layers, and its colder temperatures cause a softer scattering of sunlight. Yet despite its subtler look, Saturn's atmosphere is anything but calm. Saturn hosts giant storm systems, including periodic megastorms that wrap around the planet and can last for months. One of the largest ever recorded erupted in 2010, called the Great White Spot. It began as a bright plume in the northern hemisphere and grew into a planet-wide tempest. These storms release massive amounts of energy, generate thunder, and create massive cloud towers that rise tens of kilometers into the upper atmosphere. Lightning has been detected in these storms, and it's powerful. NASA's Cassini spacecraft recorded lightning strikes that were up to 10,000 times stronger than those on Earth. Nowhere is Saturn's atmosphere stranger than at its north pole. There, a massive hexagon-shaped storm sits at the top of the planet, a six-sided jet stream over 30,000 kilometers wide. It's so large, 4 Earths could fit across it. This hexagon is not a solid object. It's a fluid structure formed by a stable, high-speed jet stream wrapping around a central polar vortex. Its exact cause? Still unclear. Some scientists believe it's a result of standing wave patterns in Saturn's atmosphere, similar to how waves can form repeating patterns in rotating fluids. Others suggest internal heat flows may interact with rotation to create the geometric shape. Even more fascinating, the hexagon spins with the planet, but the storm at its center, the polar cyclone, spins independently. Cassini watched it for over a decade, and it never broke down. Both of Saturn's poles host cyclones, deep, rotating systems with eye-like centers. The North Polar Cyclone is surrounded by the hexagon. The South Polar Cyclone, though lacking a hexagon, is just as intense. These polar storms are larger than Earth and may extend hundreds of kilometers into the planet's atmosphere. They're warm at the center, which is unusual, and are likely powered by internal heat escaping from Saturn's interior. Unlike Earth, which gets most of its energy from the Sun, Saturn radiates more than twice the heat it receives. This internal heat likely comes from a process called helium rain. In Saturn's deep interior, helium condenses and falls like rain through layers of metallic hydrogen, releasing gravitational energy as heat. This heat fuels Saturn's storms, jet streams, and potentially even that massive polar hexagon. Saturn may look soft and serene, but its atmosphere is violent, vast, and still holds secrets science hasn't yet cracked. Saturn's rings are one of the most breathtaking sights in the solar system. Visible from Earth with even a small telescope, they've fascinated observers for centuries. When Galileo first saw them in 1610, he thought Saturn had ears. Only decades later did astronomers realize these were rings, not solid structures, but an impossibly thin and vast system of orbiting particles. Saturn's rings extend up to 282,000 kilometers from the planet. That's 3/4 of the distance from Earth to the Moon. But their thickness? Only 10 to 30 meters in most places. Think of that. Something wider than 200,000 miles, yet thinner than a city block. The rings are made of countless particles, ranging in size from tiny dust grains to massive ice boulders as large as houses. These particles are 99.9% pure water ice, with trace amounts of rock and organic compounds. They reflect up to 90% of the sunlight that hits them, giving them their iconic brilliance. There are 7 main ring groups labelled alphabetically in order of discovery: A, B, C, D, E, F and G. The B ring is the brightest and widest. The F ring is thin and braided, constantly reshaped by the tug of small moons nearby. Between the rings are gaps, like the Cassini division carved out by gravitational interactions. These rings are shaped by resonances, moonlets and subtle forces we're only beginning to understand. This is one of Saturn's biggest mysteries. Did the rings form alongside Saturn over 4.5 billion years ago, or are they much younger? Perhaps the shattered remains of a moon or comet torn apart by Saturn's gravity. Some models suggest the rings may be just a few 100 million years old, younger than the dinosaurs. One theory is that a large icy moon drifted too close to Saturn and crossed the Roche limit, the point where tidal forces tear an object apart. What remained became the ring system we see today. Other scientists propose that the rings are recycled, a balance of debris being added and lost over time. But whatever their origin, one thing is certain: the rings won't last forever. Over time, Saturn's rings are slowly fading. Particles are raining down into the atmosphere, a process Cassini called ring rain. In a few 100 million years, the rings may disappear completely. So we are lucky to live in an era where Saturn wears its crown so proudly. During the final phase of NASA's Cassini mission, the spacecraft performed a daring series of ring dives, slipping between the rings and the planet itself. It revealed that the rings are more complex than anyone imagined. There are tiny moonlets embedded within them, ghostly propeller-shaped gaps formed by invisible masses, and filaments of dust and ice extending like spiderwebs across space. Cassini even detected organic molecules suggesting that the rings may be interacting with Saturn's upper atmosphere, a subtle connection between ring and planet. Saturn's rings are a masterpiece, beautiful, delicate and temporary. A fleeting work of cosmic art, suspended in space, destined to fade, but never forgotten. Saturn doesn't just have rings, it has moons, a lot of them. As of now, astronomers have confirmed over 140 moons orbiting Saturn, more than any other planet in the solar system. Some are barely more than rubble, others are full-fledged worlds. Let's meet the most remarkable. Titan is Saturn's largest moon, and the second largest moon in the solar system, just behind Jupiter's Ganymede. It's even bigger than the planet Mercury. But what makes Titan extraordinary isn't its size, it's its atmosphere. Titan is the only moon with a thick atmosphere, made mostly of nitrogen, with traces of methane and complex organic compounds. Titan's skies are thick and orange, obscuring the surface from view. For decades, we had no idea what lay beneath. Then, in 2005, the Huygens probe, part of the Cassini mission, became the first spacecraft to land on a moon in the outer solar system. It touched down on Titan's surface and revealed an alien landscape, lakes and rivers, not of water but liquid methane and ethane, mountains and dunes shaped by wind, a surface that may hide a liquid ocean of water deep beneath the icy crust. Titan is one of the most Earth-like places in the solar system, not in temperature or chemistry, but in its geological processes. And where there's chemistry, there may be the building blocks of life. NASA's upcoming Dragonfly mission, set to launch in the 2030s, will send a rotorcraft drone to fly across Titan's surface, searching for prebiotic chemistry and exploring multiple locations. Next is Enceladus, a small, icy moon just 500 kilometers across, yet one of the most important places in the solar system. Why? Because it's shooting water into space. Cassini flew through these geysers and found water vapor, ice particles, salts, organic compounds, and even molecular hydrogen, a potential food source for microbial life. This means Enceladus has a global subsurface ocean beneath its icy shell and hydrothermal activity on the sea floor, similar to Earth's deep ocean vents. That combination, water, heat, and organics, makes Enceladus one of the top candidates for extraterrestrial life. And its geysers are venting that ocean into space, meaning we could search for signs of life without even landing. Future missions are being proposed to fly through these plumes again, or even capture and return samples to Earth. Saturn's other moons are no less fascinating. Mimas, nicknamed the Death Star moon, has a massive crater that makes it look like something out of science fiction. Iapetus is two-toned, one side bright as snow, the other dark as coal. Hyperion is a sponge-shaped rock, tumbling chaotically through space. Pan and Atlas are shaped like flying saucers, sculpted by ring material. Tethys, Dione, and Rhea show evidence of past geological activity. Each of these moons is shaped by Saturn's tidal forces, orbital resonances, and ring interactions, creating a dynamic, evolving moon system. Together, they offer an incredible laboratory for studying planet-moon interactions, icy worlds, and the potential for life in unexpected places. Saturn's moons aren't just satellites, they're worlds. They rival planets in complexity. They may hold life in their oceans, and they offer clues to how solar systems work and how ours may have formed. No mission has revealed more about Saturn than Cassini. Launched in 1997, the Cassini spacecraft traveled for 7 years before arriving at Saturn in 2004. It spent the next 13 years orbiting the planet, conducting over 160 flybys of moons, diving through the rings and sending back more than 450,000 images. With Cassini came a golden age of Saturn exploration. It dropped the Huygens probe onto Titan, unveiling a world of lakes and weather systems. It flew through the plumes of Enceladus, sampling an ocean without ever landing. It studied the hexagon, the rings, and Saturn's magnetic field in exquisite detail. And then, Cassini's time ran out. To avoid contaminating Titan or Enceladus with Earth microbes, NASA sent the spacecraft on a daring final journey, the grand finale. Cassini dove between the planet and its rings 22 times, skimming just 2,000 kilometers above Saturn's clouds. It collected last-minute data, then plunged into Saturn's atmosphere on September 15, 2017, vaporizing in the very planet it had studied for over a decade. Its final transmissions were scientific, but its legacy was poetic. Cassini transformed Saturn from a distant object of beauty into a living, dynamic, mysterious world. Saturn is more than a planet. It's a system of wonders, a place where gas swirls into storms, where ice becomes rings, where moons host oceans, and where life, just maybe, is waiting. Saturn shows us how diverse the universe can be. It stretches our imagination, it challenges our science, and it reminds us that even the most familiar celestial icons still hold unanswered questions. What lies beneath Titan's crust? What stirs the ocean on Enceladus? How long will the rings last? Saturn isn't just a destination, it's a chapter in the story of our solar system, and maybe a key to understanding others. Thanks for joining this journey to the sixth planet from the Sun. Next week we'll be visiting the seventh planet in the solar system, Uranus. If you enjoyed this documentary, like and subscribe to Skyward Space Quest, where we explore the planets, stars and mysteries of the cosmos, one world at a time.